Hello, welcome everyone to Zahid's data mining channel once again. This is a very short video where I will try to demonstrate how data mining tools and techniques can be used to analyze asset management related data and how these tools and techniques can help you in your asset management jobs. So some sort of asset management software. So in order to do that, first I need to introduce a dataset, a toy dataset, of course, an example dataset, which is synthetically created, not real dataset. Say for example, your dataset looks like this. It has 1, 2, 3, 4, 5, 6, 7, 8, 9 variables. The variables can be manufacturer, and there can be these possible types, names of the manufacturers. Age of the pump, it's a pump related dataset. Say for example, age of the pump can vary between 0 to 50, anything 0, 1, 2, 3 up to 50. Type of the pumps can be direct lift, gravity, reciprocal, etc. And all these variables, and the final variable is reliability, reliable or not. So whether this pump is reliable or not. Say for example, you already know which pumps were reliable in the past and which were not reliable in the past, and you also know various other information about those pumps. The reliability can be possibly determined through site inspections by the pump experts, etc. So you have a dataset something like this. Let's assume that you have a dataset like this. Now this is the dataset schema, and if I now develop or build or create a synthetic dataset based on that schema, that dataset may look like this. Say for example, this 17 means the 17th row in your dataset, and that row is about a pump, and it says that it is a flat pump, it's 50 years old, it's a direct lift, blah blah blah, and no, the pump was not reliable. Look, again I'm reiterating that it's a completely synthetic dataset. Please do not try to link it with any real life scenario. I'm just making up a dataset to demonstrate this. Say for example, the pump is not reliable, and you may have more and more of this data. Now the problem is, when you have data like this, it's very difficult for you to discover a pattern from it, to discover knowledge from it as to which pumps are generally found to be reliable and which are not reliable. What is the pattern? What are the patterns that some pumps are reliable and some are not? So that can be very difficult, but now I will demonstrate how you can actually discover that knowledge very easily using data mining tools and techniques. I will use a freely available data mining software which is called Weka. You can freely download it from the internet, and you can start using it just by double clicking on it when you have downloaded it. And when this Weka GUI chooser appears, you can open an explorer, and you can actually then open your data set in this Weka explorer. I have already uploaded a number of videos on how to download Weka and how to use Weka Explorer and how to use data mining tools and techniques there in Weka. So this is what you can see now is my data mining channel called Zahid's Data Mining Channel. You can Google it, search for it in YouTube, and there are number of videos that actually will explain how to use it. For example, this video decision tree software, or this video data mining software, and this video clustering software. These three videos, in addition to quite a few other videos on various data mining approaches, techniques, can actually explain how to use Weka. So these three videos, I strongly suggest that you can view these three videos to see how to actually download Weka, and then this video will make more sense to you. But you can just watch this video first, no problem. To apply this Weka software on your dataset, you need to open your dataset in Weka. So for example, this is the dataset that I synthetically created. I have shown you before, and you need to create an ARFF format of that dataset, which is nothing but a text file with some header. I will show you in a minute. This is how an ARFF file looks like. It's nothing but the information of the pumps as you saw before in your Excel file. So each line here, so line number 14 is there, xylem 45, direct lift and high, etc. So this is a .txt file sort of .txt file. It's a text file or CSV file, and then you have the extension called ARFF. All you have extra is these few lines at the top of the of your data, and these lines are like, for example, at relation asset management. So that says what is the name of the file. That's asset management.arff file. And then it says add attribute. So these are the attributes. Manufacturer, so you remember the first attribute was manufacturer, and it can be, say for example in this example, xylem or fleet. So you can mention that what are the possible values of those manufacturers. And then the second attribute was age, if you remember from the slide that I showed before, and the age is numerical because it can vary between 0 and 50. Third attribute was type, and it has 3 possible types, in this case direct lift, gravity, reciprocal, etc. So you are actually defining what are the possible variables that your data set has and what are the possible values of those variables. Not that every record will have each of those values, but every record needs to have one of those values. So that sort of thing. And then you are also saying that finally you have an attribute called reliable, and the possible values are yes and no. And then your data starts. So there you go. From this point and onward, this ARFF file, .arff file, will have all this data directly copied and pasted from the Excel file. You can open this .arff file from this Weka Explorer by clicking on this open file link. Then you will have a window like this. You have to go to the folder where that .arff file is. You have to then select it, asset management.arff, and then open it. As soon as you open the file, you can actually see the data and various information on that data, some sort of distribution of the data, etc. Say for example, if you click on reliable, these are the variables. So if you click on reliable, you can see in this data set you have 25 reliable pumps and 41 non-reliable pumps. If you click on manufacturer, you can see that there are 39 xylem pumps and 27 fleet pumps, and out of 39 xylem pumps, you can see quite a few of them are reliable and many of them are actually not reliable. So you can see the red is not reliable and blue is reliable, and you can actually see this from here. Blue 25 that's reliable, and red 41 is not reliable. So you can see that how is the distribution of this data set in terms of pumps. For example, you can choose age, and you can see that when age increases of the pumps, then between possibly 40, 35, 38 and 50, you can see all of these pumps are actually not reliable. And then below age, when age is 26 to 38, then most of the pumps are not reliable, some are reliable. So you can see some pattern from here. But again, these are not very conclusive, so you can actually apply classifier. And how to do those classifier, how to download classifiers, as I said, I have shown it in my previous videos. You can watch, but here also I can show you quickly that here I will open one of our classifiers, sys4, that is freely available as well in Weka. You can install sys4 using my previous videos, and then I'm opening that classifier and I'm building, say for example, 10 trees, say 1 tree to start with. I will build 1 tree. Let's say first we build a classifier from J48. Just build 1 tree from J48, and there are a lot of options for you to choose. You can choose different options, but maybe you can start with a default option. And when you click start, as soon as you click start, it actually builds a decision tree. They call it a decision tree, which is kind of a logic rule that why some pumps are reliable and why not. Let me explain it. It says if age is less than equal to 30 and performance is less than equal to 3, then they are not reliable. That's the pattern it finds from the data set that you have seen before. And it also reports you that there are 6 such pumps and all of them are actually not reliable. When age is low but performance is less than equal to 3, that means they are not very well performing, then they are not reliable. But when age is less than 30 but performance is greater than 3, okay, and then they are all reliable. There are 28 such pumps, only 3 of them are not reliable. So that means out of 28, 25 of such pumps where age is less than 30 and performance is greater than 3, they are all reliable. So that's a strong pattern you can think, because there are 28 such pumps. It's not a small number, given that this whole data set has only a few records, maybe 60, 65, 67 records. What is the total number of record? Let me now, total number of instances 66. Yep. So out of 66 records, 28 of them are in this folder, in this pattern. So that's a big number, and also 25 of them are reliable. So that's a good pattern. So you can see how reliability can be checked, and also you can see if age is greater than 30, then they are not reliable. 32 pumps there and all of them are not reliable. You can also visualize this tree. If you click on this and visualize tree, you can see a tree that you can visualize. So that same rules can be seen. If age is greater than 30, they are not reliable. There are 32 records there. So while using J48, you can build just one tree and you can learn just one pattern. You can actually use our technique as well, SYS4 or Forest PA. These are our techniques. So you can also build a SYS4 tree. Say for example, instead of 60 trees, I want to build 10 trees with 2 records per leaf, and I can start and it creates 10 leaves. So previously you saw just one tree through J48, but with SYS4, our technique, you can actually build a number of trees, and this is commonly known as decision forest instead of decision tree. Here you can see actually multiple patterns. So not just one pattern, but multiple set of patterns. Say for example, when performance is less than 4, then actually they are not reliable, and you can see 16 records and all 16 are not reliable. But when performance is greater than 4, then it depends on age. So it's different style of pattern. For example, if I go here, it also says not only just performance but capacity of the pumps can also determine whether they are reliable or not. Remember, this is a synthetic data set and it doesn't have many patterns in it. In real data set, you can actually apply these and learn a lot more information. You can also learn more information through clustering in addition to building decision forest. As I showed before, through classification you can build clusters. So if you click on clustering and then you can choose a clustering technique, we have our clustering technique there called GenClus++. If you choose it and if you say just cluster these records, then it will automatically cluster all these records. Clustering means like grouping similar pumps in one group and dissimilar pumps in different groups, and then you can see that you have actually got 10 different clusters. Okay, 10 different clusters, and you can choose to use classes to cluster evaluation. So that means after clustering, it will tell you which cluster has reliable pumps and which cluster has non-reliable pumps. For example, you can see that cluster 3 here has 2 pumps and both of them are reliable, whereas cluster 2 has 2 pumps where both of them are non-reliable. Then in order to discover knowledge, you can just look at the cluster properties, cluster 2 which are non-reliable and cluster 3 which are reliable. You can see cluster 2 has age 34. Generally that's the mean average age of all pumps in cluster 2, and cluster 3 has age 22. Average age is 22, and then performance is 9 and performance for cluster 2 is 1. So you can see maybe performance is making the big difference between cluster 2 and cluster 3, because when performance is high, then cluster 3 has two both reliable pumps. So you can discover knowledge like this, and it definitely requires a lot of analysis, etc. But these tools can actually help you to analyze your data a lot better than otherwise you can do manually. For example, one point worth mentioning, that when you build a decision tree from your dataset, it just builds it automatically. It does not require any user input from you, any domain expertise from you. For example, you did not say build a tree based on age, on performance. It automatically found that age is an important factor, and thereby it built a tree based on age. I hope this short video was helpful. Thanks for watching.